I have these two rod A and rod B. From somewhere the signal is coming in any direction. This then this two rod, this is antenna A, and this is antenna the B. Suppose this signal x t, which can be characterized by a sine omega t. If this signal is received on A as the received by A is x1t is a sine omega t, and if this received by B has some phase differences, if I am assuming the reference point at A as this point, but I am assuming that B will receive this signal after this phase difference phi. Okay, this phase difference is phi. After this time, this interval, this signal will reach here, sine omega t plus del phi, and this del phi term is called phase difference or time delay. Then the calculation, we know this W is the radian. Suppose our frequency of the signal is f, then this W can be represented as making the circle f times in 1 second, means 2 pi f is W, and the phase difference is time delay. Similarly, the time required to travel, the difference time is this, yes, distance by velocity. So the phase difference is omega t is 2 pi f dot d by v. Suppose if this antenna is of the plane, suppose this is the plane, suppose this is this is the plane, and from here, from the station, this station can be anywhere. If this station is transmitting the signal, then there is one equipment called there is called the equipment called NDB. Okay, this has two antennas, and using the same principle, this A received and B received, if this plane is making some angle with this, let us consider this plane is now here. Yes, then these two antennas will receive at the same time. If we know these if they are in the line of sight, if the plane is here, there will be some phase difference. And calculating this, the phase difference del phi, the pilot have an indicator, we can see on the cockpit. This the indicator, then this indicator will be deflected on the basis of this phase difference.